Midday shatters without a sound. A sky once washed in blue turns the color of ancient ash. Birds spiral, confused by a darkness deeper than any eclipse. Oceans of shadow spill across continents, slipping through cities, drowning landscapes in ink. 8 minutes ago, the sun was still shining. Now, its last rays brush the upper atmosphere like ghostly fingertips, and then they too are gone. Space does not erupt in violence. No flash, no shockwave. Only absence. Where the sun once burned is now a perfect disk of darkness, a circle so absolute it seems to drink the stars at its edge. Its boundary is crisp yet impossible, like a hole punched through the sky. This is a black hole the mass of our star, compressed into a sphere scarcely wider than Earth, and yet the planets, including our own, continue their orbit obedient to the same gravity that held them a moment before. Here lies the first paradox. By mass alone, nothing changes. Earth does not spiral inward. It continues its dance at one astronomical unit. The same speed, the same path. From space, the geometry is unchanged, an invisible center tugging at the planets with precisely the same pull. Gravity is blind to light. The solar system, in its clockwork precision, turns on in perfect silence. Yet on Earth's surface, the story is entirely different. Without sunlight, the atmosphere begins its slow exhalation of heat. The blue sky fades to black as scattered sunlight ceases. Air currents falter, winds soften, and the first whispers of infrared cold creep across the planet. In hours, temperatures plunge, photosynthesis stops. The auroras, born of solar wind, flicker and vanish, leaving the poles in spectral stillness. Across the continents, humans stare upward, searching for the impossible. They expect flames, eruptions, the sun's swelling demise. Instead, they meet a hole in the sky, a silent dark eye staring back. Some wonder if it's an illusion, a cosmic eclipse. But astronomers know instantly, a star has died without dying, transmuted into gravity itself. Freed from the sun's glare, stars blaze brighter than at any time in human history. The Milky Way unfurls in impossible clarity, each filament a frozen river of light. Planets glow as dim pinpricks, reflecting only the faintest echoes of starlight. Even at noon, its very existence reshapes perception. Light from background stars bends as it passes near the event horizon, creating a ring of warped brilliance called an Einstein ring. The sky appears as if painted on glass, warped inward, constellations stretched and curved. The sun's familiar position becomes a window into another region of the cosmos. Meanwhile, on Earth, time and biology begin to slip. Crops wither in sudden winter. Power grids strain under artificial lighting and heating. Within days, oceans begin to crust at their surfaces. In weeks, atmospheric gases condense. Earth starts to resemble its own cryogenic twin, a frozen marble orbiting a ghost. The third reveal arrives as scientists calculate the timeline. Earth's orbit, stable though it remains, buys only time. Without solar input, the surface will freeze to hundreds of degrees below zero within a year. The deep oceans hold warmth longer, perhaps decades, but the biosphere is doomed unless another energy source is found. The planet, for all its orbital grace, becomes a drifting cryogenic arc around a singularity, some dream of escape. Rocket engines roar to life in frantic tests. Could humanity flee outward to distant stars before the cold finishes its slow conquest? But the distances dwarf even our boldest visions. At current technology, the nearest star would take tens of thousands of years to reach. Gravity has not trapped Earth, physics has trapped time. Another paradox emerges. The sun's mass is too low to become a black hole naturally. In reality, it would die as a white dwarf, cooling over trillions of years. This black hole sun is an impossibility, a thought experiment carved into the night. Yet here we are, orbiting the hypothetical, living inside an equation, once scribbled in the margins of Einstein's theory. As days blur into perpetual night, the very texture of Earth changes. Ice advances from the poles like glass poured from the sky. Clouds freeze in midair and drift downward as crystal snow. Cities glow in artificial daylight, tiny islands of light on a frozen continent. And yet above them, space remains majestic, untouched, perfectly ordered planets in their eternal ballet, circling a void. From the moon, the view is even stranger. Its gray plains glow with starlight, its horizon crowned by the dark orb of the black hole sun. Around that orb, a thin halo of distorted starlight shifts as one moves, a mirage of gravity. The moon too remains in orbit, faithful to Earth as Earth is faithful to the void. Nothing in celestial mechanics has changed. Everything in experience has. This is the fourth reveal. The solar system's death is not fiery, but frozen. Not an explosion, but a long unspooling of heat and light. The true threat of a black hole sun is not gravitational, it is thermodynamic. Without a star's radiance, life becomes a fleeting spark in a sea of dark entropy. And yet, there is an eerie calm to it all. Spacecraft beyond Earth still glide on their trajectories. The distant probes, Voyager, Pioneer, New Horizons, drift outward under the same laws as before. Only their power fades, their cameras now capturing starlight undimmed by the sun's blaze. They, like us, are relics of an age of light. The black hole itself is silent. No accretion disk, no jets of plasma, only darkness. If one could drift near its horizon, tidal forces at one solar mass would be mild, not the spaghettifying extremes of supermassive cousins. A spaceship could orbit safely just outside the event horizon, forever circling a well of spacetime, but no light would ever escape to mark its path. Back on Earth, myths reawaken. Ancient stories of dark suns, of gods swallowed by serpents, of endless night. In temples and observatories, people trace the warped constellations, seeking meaning. Science provides the mechanism. Myth offers the metaphor. Together, they frame a truth too large for the human nervous system. The sun, our giver of life, now a ghost of gravity. The chapter closes on a single image. Earth, half lit by city lights, half cloaked in growing ice, sweeps along its orbit, as it always has. In the center of the solar system is nothing the eye can see, only a perfect circle of night, bending the stars around it. Silence radiates outward, an invisible tide, and through that tide flows a question. Cold and immense. If the sun becomes a black hole tonight, can humanity escape its darkness? Or will the real event horizon be the limits of our imagination? Silence radiates outward, an invisible tide, and through that tide flows a question. Cold and immense. If the sun becomes a black hole tonight, can humanity escape its darkness? Or will the real event horizon be the limits of our imagination? A century and a half before, Einstein bent the fabric of spacetime to minds in Europe glimpsed the edge of an abyss. The year is 1783. In a letter written by the English clergyman and natural philosopher John Michell, the first seeds of a cosmic shadow take root. By candlelight, with quills scratching across paper, Michell imagines a star so dense that light itself cannot escape. No one has yet uttered the words black hole, but the idea of a dark star is born in ink in speculation. He writes of escape velocity, the speed an object must reach to flee gravity's pull. Earth's is modest, only 11 kilometers per second. The sun's greater. But imagine, he whispers to the Royal Society, a sphere so massive its escape velocity exceeds even the speed of light. According to Newton's optics and mechanics, light is made of particles. Thus, gravity should act upon it. Such a star would be invisible, detectable only by the motions of its companions. A cosmic hunter's trap, dark and silent. Across the channel, the French mathematician Pierre-Simon Laplace is also listening to gravity's darker music. In 1796, he writes of stars whose light cannot reach us. Bodies hidden from view, their existence betrayed only by the dance of nearby matter. In an age without telescopes powerful enough to see the farthest planets clearly, this is radical thinking. Yet Laplace, like Michell, senses an unseen architecture to the heavens, a shadow world built of invisible suns. But their idea is born into a universe, still framed by Newtonian absolutes. Space and time are fixed backdrops. Light is a stream of corpuscles. Gravity is a force acting instantly at a distance. In such a cosmos, dark stars are curiosities, not destinies. The notion lingers, largely ignored, like a seed falling on stony ground. 2 centuries will pass before the soil becomes fertile. Throughout the 19th century, astronomers stretch their telescopes skyward. They chart nebulae, measure binary stars, and discover the subtle wobble of unseen companions. Yet the sun remains the ultimate anchor of certainty. It burns, it warms, it shines. To imagine it could end in darkness feels blasphemous. But the industrial revolutions, furnaces, and new physics hint at a cosmos ruled not by permanence but by transformation. Energy can change form, but it cannot be created or destroyed. Stars, too, must obey. Then the mini-reveal. The sun we know, the great yellow dwarf of our sky, is far too light to collapse into a black hole. When its fuel runs out billions of years hence, it will swell to a red giant, shed its outer layers, and leave behind a white dwarf, a corpse of carbon and oxygen glowing faintly in infrared. Only stars many times its mass can end as black holes. Mitchell and Laplace predicted a fate our sun can never reach naturally. The black hole sun is for us. Physics itself fractures and reforms. Einstein's general relativity unseats Newton's comforting absolutes. Gravity is no longer a force, but the warping of spacetime by mass and energy. Light is not a particle alone, nor a wave alone, but something stranger, bending with the curvature of the universe. The seed Mitchell planted in Newtonian soil germinates at last in Einstein's geometry. In 1916, only months after Einstein publishes his theory, Karl Schwarzschild, serving on the Eastern Front during World War I, sends back a solution to the field equations, a sphere where space-time curves so steeply not even light can escape. The Schwarzschild radius becomes the mathematical boundary of a black hole. What Mitchell and Laplace imagined with Newtonian, escape velocity now emerges from relativity as a horizon of no return, yet still disbelief reigns. Astronomers and physicists consider these solutions to be mathematical oddities, not real objects. How could something exist that cannot be seen? How can the universe contain singularities, infinities of density, and zero volume without breaking itself? The human mind resists the invisible, especially when the invisible means annihilation of the known dot in observatories across Europe and America. New instruments probe the sky. They detect stars orbiting emptiness, gas clouds accelerated by unseen forces, X-rays from deep space. By mid-century, evidence accumulates that massive, compact objects exist, neutron stars, then something darker. Gradually, black hole ceases to be a poet's nightmare and becomes an astrophysical reality. But the emotional undercurrent remains the same. Dread of invisible gravity, to look into the sky and know that somewhere, just beyond the reach of telescopes, are wells of spacetime from which no light escapes. This is a new kind of cosmic horror. It is not the terror of comets or eclipses, but the terror of erasure, of crossing a line and never returning. At each stage of discovery, the sun itself becomes more mortal. Stellar physics reveals its hydrogen furnace, its finite fuel, its inevitable metamorphosis. We begin to see stars as processes, not eternal torches. Nuclear fusion replaces divine fire. Stars are born, live, and die. Some collapse into dwarfs, others into neutron stars, and the heaviest into black holes. Our sun, humble by comparison, is spared the ultimate plunge, but the possibility remains, like a blade held to our collective throat. If somehow the sun were forced beyond its limit, the sky we trust would vanish overnight. This is the paradox our documentary lives in, a cosmic what-if, built from the equations of Mitchell, Laplace, Einstein, and Schwarzschild. The idea of invisible suns, once whispered in candlelit rooms, now informs gravitational wave observatories, black hole imaging, and the mathematics of the early universe. The seeds planted in the 18th century have become forests of theory in the 21st, and yet the question persists, glimmering between science and myth. When humanity peers into the night sky and sees stars orbiting emptiness, is it seeing the universe's machinery or its scars? When the sun dies, will it leave behind a white dwarf as predicted, or does some more exotic, unthinkable fate await? We end this chapter not in the present, but at a threshold, as though standing in Mitchell's study or Laplace's salon, looking over their shoulders at ink-stained papers covered in strange calculations. Outside, gas lamps flicker, and the night sky over Europe is clear and unpolluted. Above them, invisible, the true engines of the cosmos churn. Black holes, then unknown. Already shape galaxies, already bend time. Already teach space how to curve. The camera pulls back from their faces, from the glint of candlelight on brass instruments to the vast dome of stars. For a moment, The sun seems eternal, its light an unbroken promise. But the equations whisper otherwise. In those numbers is the knowledge that stars are not immortal and that even the giver of light may become the thief of light. Somewhere in that darkness, the future chapters of our story wait, spacecraft poised, civilizations tested, and a black hole sun haunting the horizon of possibility. The dreamers have measured the void. The next question is whether we can live within it. Somewhere in that darkness, the future chapters of our story wait, spacecraft poised, civilizations tested, and a black hole sun haunting the horizon of possibility. The dreamers have measured the void. The next question is whether we can live within it. The black hole sun hangs at the center of the solar system, a silent weight where radiance once burned. Around it, the planets move as they always have, tracing invisible ellipses. Earth still arcs at 93 million miles, one astronomical unit locked in a dance it cannot feel but cannot escape. Gravity holds steady. It is light that has vanished, not pull. This is the first paradox of our new cosmos. The sky can die without the orbits changing at all. The mathematics is merciless yet elegant. The gravitational field of a one solar mass black hole is indistinguishable at a distance from that of the sun itself. Newton would have recognized the equations. Einstein would have recognized the geometry. No spiral into darkness occurs, no sudden fall. Earth, Mars, Jupiter all continue their slow ballet as if nothing happened. But the stage lights are out and the dancers move in silence. With the sun gone, the thermostat of our world clicks to zero. Within hours, the upper atmosphere cools, infrared energy radiating into space with no replenishment. Average temperatures fall below freezing within days. In weeks, oceans crust with ice. Carbon dioxide begins to snow from the air, forming pink frost at the poles. The great currents of Earth, the Gulf Stream, the jet stream, falter, leaving continents under unmoving blankets of cold air. Life retreats underground into oceans or into extinction. Here, the mini reveal, though our orbit remains stable. The biosphere unravels as though gravity itself had betrayed us. We are not prisoners of pull, but of heat. The sun's energy output, 3.8 times YD watts, once bathed Earth in a steady 1,361 watts per square meter at the top of the atmosphere. Now that number is zero. No civilization can replace such power easily. Space-based telescopes turn their gaze toward the new center. The black hole itself is invisible, but its effect on light is not. Background stars smear and bend into arcs of impossible geometry. Constellations ripple like reflections in a dark lake. The Einstein ring of warped starlight glows faintly, a halo of bent photons around the void. The night sky is no longer a fixed map, but a living lens. Astronomers, awestruck and terrified, realize the solar system has become its own gravitational observatory. Yet some see opportunity amid the silence. If gravity is unchanged, spacecraft can still orbit, slingshot, and maneuver as before. The inner planets, cooling rapidly, may be mined for resources. The giant planets still retain their vast stores of hydrogen and helium, potential fuel for fusion. A whisper spreads, could we build arcs, powered by artificial suns, to drift between the stars? Engineers sketch designs of fusion drives the size of cities. They imagine hollowed-out asteroids spinning for gravity, habitats shielded by ice and lead. Nuclear fusion, the very engine of stars, becomes humanity's only hope to recreate daylight. Yet the scale is staggering. Even the most ambitious propulsion systems today would take tens of thousands of years to reach Alpha Centauri. Survival under a black hole sun would require patience on geological timescales. A rival school argues for staying put. Jupiter, with its immense mass and storms, could be harnessed. Its gravitational well and its enormous supply of hydrogen might be turned into a vast energy reservoir. Perhaps a chain of orbital reactors could harvest what little radiation still lingers near the black hole, or capture the final trickle of solar wind as it collapses inward. Such dreams resemble medieval siege plans, elaborate, desperate, and beautiful in their futility. Meanwhile, Earth continues its freeze. The first 100 meters of ocean solidified. But beneath the ice, the water stays liquid for decades, warmed by geothermal vents. Microbial life clings to existence. Human cities cluster around nuclear plants, drilling into Earth's crust for warmth. The planet resembles Europa more than Earth. An icy shell over a hidden ocean dot another mini-reveal, the black hole sun. At only one solar mass, exerts tidal forces no stronger than the sun's. Unlike its supermassive cousins in galactic centers, it would not spaghettify nearby objects until very close. A spacecraft could skim the event horizon, orbiting a star reduced to a city-sized shadow, and experience only mild stretching. This proximity offers strange possibilities for studying relativity directly, but it also offers the final temptation to cross the horizon and vanish. From the outer planets, the view is stranger still. Saturn's rings gleam faintly in starlight, casting icy shadows. Neptune glows like a sapphire in the dark. The heliosphere shrinks, no longer inflated by solar wind, leaving interstellar particles to drift inward unopposed. Cosmic rays, once deflected, now flood the solar system. Another invisible hazard for any remaining life. On Earth, the night sky becomes both a map and a verdict. Without the sun's glare, galaxies unseen for millennia reveal themselves. The Andromeda Galaxy is a delicate smear of silver. Globular clusters sparkle like dusted diamonds. But this gift of clarity is also a countdown. Each star shining above is unimaginably far away. The nearest lifeline lies across light years of cold vacuum. How long does humanity have? The answer is a gradient, not a date. Surface life begins dying within weeks. Complex ecosystems collapse in months. Oceans freeze in years. With enough engineering, pockets of warmth could endure for centuries. But each step is a retreat from the surface, a retreat from the sky. Without a new source of power, the Earth becomes a sealed vault, drifting in eternal night. This is the existential stake of the black hole. Sun, not a sudden apocalypse, but a slow attrition of heat, light, and meaning. Gravity alone cannot kill us. It simply watches as time and temperature do the work. Like a patient predator, the singularity at the center neither moves nor strikes. It waits, and still. Paradoxically, the solar system's dance endures. Mercury, Venus, Earth, Mars, frozen beads on invisible strings. The outer planets tracing colossal ellipses. All of it, unchanged in motion, changed utterly in spirit. A dim clockwork wound around a singularity, ticking without a hand to mark the hours. The camera drifts outward in imagination, past the Kuiper Belt, past the scattered disk, into interstellar space. The sun is now a darkness amid darkness, yet its gravity remains a beacon to the planets. From far away, the solar system looks like an ordinary system of dark rocks, orbiting an unseen mass. Only close in does the absence of light betray the truth in the end. Our third act is a study in contrasts: motion without warmth, stability without safety, physics without mercy. The mathematics that promised permanence become suspense. Escape requires not breaking gravity, but outlasting time, or forging a new sun from our own hands. The chapter closes on a haunting image. Earth, its oceans sealed under ice, circles an invisible center. Above, stars warp and shimmer around a perfect hole in the sky. In the radio quiet of deep space, no dawn comes. Only the slow drift of a planet orbiting a ghost star, carrying a fragile species that has always lived by borrowed fire. Earth, its oceans sealed under ice, circles an invisible center. Above, stars warp and shimmer around a perfect hole in the sky. In the radio quiet of deep space, no dawn comes. Only the slow drift of a planet orbiting a ghost star, carrying a fragile species that has always lived by borrowed fire. For 4.5 billion years, the sun has burned a heartbeat of fusion at the center of our lives. Every leaf, every tide, every shadow was timed to its pulse. Now that heartbeat is gone, replaced by a silence so complete, it feels like an echo of nothing. Light, the oldest companion of life, has vanished. What remains is the memory of warmth, drifting outward in a planet's cooling crust. Light was never merely illumination. It was chronology, metabolism, orientation. Diurnal cycles taught cells to divide, animals to migrate, minds to dream. Without it, time blurs. The planet drifts into an endless midnight, where clocks become the only measure of passing days. As Earth cools, it is not only oceans and air that freeze, but also the human sense of permanence. Civilization itself was built on sunrise. The solar system endures as an exquisite machine. Gravity holds its planets and moons in perfect tension, each orbit a chord in a silent symphony. But the music has lost its rhythm. The black hole sun exerts the same pull as before, yet its invisibility renders the orbits ghostly. It is as if the solar system has been hollowed out, leaving only the shape of its former self. Gravity remains, meaning dissolves. This is the closing paradox. Mass without light, motion without growth, structure without story. The invisible sun rules with a gravity as steady as ever, but offers no radiance, no sustenance, no hint of dawn. Humanity's question is no longer how to live under gravity, but how to live without light. Some imagine outward expansion, arcs launched into interstellar night, carrying ecosystems like bottled summers. Propulsion systems, the size of cities, powered by fusion, drive slow arcs toward the nearest stars. Each ship is a fragment of Earth, a seed cast across a cold field. The timescales dwarf generations. Success would mean societies evolving in transit, becoming as alien to their ancestors as planets are to comets. Others imagine inward retreat. Vaults drilled deep into Earth's crust, heated by geothermal energy, fed by artificial photosynthesis under nuclear glow. Cities without sky, seasons replaced by programmed light cycles, a species slowly adapting to cavern life. Here, the dream of exploration gives way to the instinct of hibernation, the curling inward of a once aspiring civilization. Both visions share a truth. Humanity must reinvent itself to persist. Light can be manufactured, but not endlessly. Heat can be stored, but only temporarily. The sun gave freely what no technology can provide without cost, a continuous, stable flow of energy across billions of square kilometers. In its absence, life becomes an accounting exercise in joules and watts, a dwindling ledger of fire. Freed from daylight, galaxies bloom across the firmament like cosmic frost. The black hole sun itself is invisible, but for the halo of warped starlight at its edge, a permanent eclipse at the heart of the sky. Looking up, survivors see not their star but a hole through which the universe peers back. Here lies an unsettling revelation. The solar system has not been destroyed, it has been transformed into a monument. Each orbiting body testifies to a physics that continues even when life fails. Earth is now a black ice marble circling an invisible core, a fossil planet in a cosmic reliquary. The sun's death has turned our home into an exhibit in a galactic museum. No one will ever visit, yet within this frozen tableau flickers one last ember of agency: the human capacity for imagination. It was imagination that first foresaw dark stars and black holes, that built telescopes to measure invisible forces, that launched machines beyond the heliosphere. It may be imagination, too, that finds a path beyond this darkness, not just a path of propulsion, but a path of meaning. For even as physics governs bodies, stories govern minds. In the absence of daylight, myth rises again. People speak of a rebirth star, of a cosmic dawn beyond the event horizon, of an unseen passage to another universe. None of these tales are testable, yet all offer a counterweight to the black hole's silence. Where science runs out, narrative begins, a way to make darkness bearable. The camera now pulls back. Earth becomes a pale fleck, then disappears. The planets shrink to motes of dust, circling nothing. The solar system itself recedes, a diagram of ellipses drawn on black velvet. Beyond the heliosphere lies interstellar space, no longer lit from behind, but filled with raw starlight. The black hole sun fades to a single gravitational coordinate, a point in a cosmic map. In this final view, we see ourselves from the outside, a species born of a star, now circling its absence, a civilization raised on light, now learning to navigate darkness. Gravity has not imprisoned us. We have always been free to move. Yet the question lingers: can we ever truly escape the pull of our own origin? The last image lingers like an afterglow. Earth, silent, frozen, black ice reflecting starlight, loops endlessly around an invisible master. Above it, stars warp in delicate arcs, a permanent reminder of the well hidden at the center. Beyond the solar system stretches a boundless dark, cold and eternal, but also waiting, as if for a spark yet unborn, and then a final whisper, unresolved. Perhaps escape from gravity is possible, perhaps even escape from night. But can any species escape itself? its cycles of rise and ruin, its dependence on the fires that birthed it. This question, suspended like a comet on its long orbit, carries forward beyond the frame into the next act the universe will write. And then, a final whisper, unresolved. Perhaps escape from gravity is possible, perhaps even escape from night. But can any species escape itself, its cycles of rise and ruin, its dependence on the fires that birthed it? This question, suspended like a comet on its long orbit, carries forward beyond the frame into the next act the universe will write.